A lot of beginners are really confused right now. They saw a lot of tutorials on TikTok showing how to make arcs. When they try folding the same way, they're always off by a millimeter or two. They don't know exactly why. So I decided to make a video to dive into some of the finer details about arcs. For example, our current height is 40 units. RS means external, remember. External and internal dimensions are different. First, we calculate. First, the arc length equals 2 times 3.14 multiplied by, for R20, subtract half the material thickness, which is 1.0, so you calculate it as 19.5. That gives the neutral layer, then divide by 4. It's not a quarter circle. The calculated arc length comes out to 30.6. Arc length equals 30.6. So its reserve size is equal to our height of 40 minus our value is 20. No, that's not right. Quick position. Theoretically, here we calculate that it should be equal to 30.6 and then add our reservation of 20. It should be 50.6, but if you calculate it this way, you are wrong. For high quality stainless, apply bending film before bending. What we're using is 1.0 material, and for arcs, we use an 8V die. The larger the V, the better the arc corner looks. First, make the first cut. You probably already know the bending angle for the first cut, but just to be clear, I divided it into 10 segments, which requires 11 cuts. With 11 cuts, each cut is about 8-point-something degrees, which results in a total of around 172 degrees. For the first bend, we filled it at 172. What about the crease position for the first bend at 178? First crease here. Let's measure this crease point. What about the first crease point? Should be our length cross allowance minus half the plate thickness. Subtract about half the plate thickness. In other words, our first bend should be set at 50.1. After achieving the desired creasing angle and bending dimension for the second cut and onwards, reduce by 2 to 3 degrees from the first cut. Depending on the gap difference, the angle for our R10 might be 7 to 8 degrees smaller. After completing the first bend, proceed with the subsequent bends in sequence. After a few bends, measure the angle. If incorrect, avoid tapping or adjusting the die manually. Adjust deflection compensation. Angle's perfect, machine stable. Let's continue the process.
927,000. You go.
Especially the final bend. We still have one bend left. The final bend allowance should be 20 millimeters. We subtract half the plate thickness in the first cut, so the final cut does the same. So the marking position for the final bend should be 19.5. It will reach the 90 angle. The dimensions won't change exactly as expected. So during the cutting process, we must also account for this. We need to adjust the cutting dimensions accordingly. Now, let's take a look at the overall shape of the bending. This film here is the bending film. I'll remove it now. Let me show you without applying any film. For 8K mirror stainless steel plates and high quality products, applying film prevents pressure marks. That's what happens when no film is applied. Same material, same angle and pressure. Bending results. You can see the difference now. As for this film, I use one that's 0.3 millimeters thick. Big discounts during the shopping festival.